Because you actually have to subtract 1. Because you know how it was like -1 plus.
Wait, I thought
Or -3, doesn't matter.
Yeah.
isn't the xi term negative is -3 minus 5 over ni?
Plus.
Plus.
AI plus. Because you start at this side and you go up.
I know,
It's
that
always
was throwing me off too, and then I was like, no, it's the
All right.
8 term plus this.
All right, guys. So as always, if your mistake was something minor, like you made a negative or plus sign, or you left a 2 out, you're not going to lose as many points as if you just showed me that you had no idea what to do. Right? So if you at least got the process right, you'll get most of the points.
I completely.
All right. All right, SS. Deep breath.
6 plus 3.
Let it go. I'm not going to sing. Get enough from that knee, for my niece. Jeff, I want to sing to you one more time.
I saw that movie last night. It's not as good as I thought it would be.
Oh, yeah, I guess you're right. It was hyped up a little bit. It was good, but it wasn't like, whoa.
I wasn't amazed. I was like, oh, that's cool, but it wasn't like.
I agree. All right, guys, help me out here. If I had to integrate, so we've done stuff like this before. If I had to integrate this, yeah, it would be cosine, right?
It would be 1 minus cosine squared.
Negative, and then of course kill the 2, right? All right. So today we're going to learn something a little more refined. If the inside function, here's where everything comes down to. When do I have to use chain rule for differentiation? When I have. Say again.
Function within a function.
Good. There's something more than just x inside of a function. So when you integrate, if I have something inside of something, I have to take care of it somehow. The more complicated that interior function gets, the more I want a better way to do things. So let me remind you guys, recall. I think I might have talked about this before, I can't remember now. If I had this, actually I put this on my Math 90 bonus question. Factor that. Right, and of course the first thing to do is to start cubing it. Oh shit. You know, what is bonus? I can do what I want to. What you do is you realize that it is in a form. What form is it in? Who remembers? Difference of cubes. It's just the form is hidden under all the messiness. So to get the messiness out of the way, you let this be u. And you let, normally v, we use v because it's next in line. And let v be that. So then I still maintain the form of it. In fact, I've done more than that. It's still the same problem. Because u is that, and v is that. So it's the same problem, it just looks better. So somehow this ties into today. With calculus, right? We're not going to focus, don't get your hopes up. But yeah, cubes, it's better than what we've been doing. Come back to cubes. And how do I factor this?
So it's a squared, or u squared minus v squared.
Little dude only gets one of each, right? I always tell my students, little dude, big dude. So little dude gets one of each. The big dude gets
U squared.
2 of each.
Minus uv.
No, now I talk about Pulp Fiction. When I teach this about Pulp Fiction, remember that character that had to come in? The guy who got his brains blown out in the back seat? And the guy had to come in the cleaner? Right? The cleaner. So this middle guy's the cleaner. He's got to be opposite sides so he can clean UV. You better know how to factor your cubes. It might come up in your future sometime. Well, partial fractions a little bit. We'll be getting into that. I don't know if you guys remember partial fractions. They have a purpose. They have a reason to live. All right, and then of course I'm not done with this. The very last thing I do is put that stuff back in, right? Blah blah. I just replace u with what it is and v with what it is. Are you guys with me? Mm-hmm. So we can employ this. Now, last time I got a little bit into this. Let me get you guys to remember this from last time. Who remembers? Like if I had this. We talked about this last time a little bit.
Oh, so that is x. So it would be
X plus 1 plus 2.
Say again. So really what I'm asking you is the integral of square root of something, d that thing, right? Isn't that what that's asking? So again, I've got something I can replace this with u to make it look better.
You just move it to 1.
Stay with me now. Some of you guys know u sub, you're not sure what the hell I'm doing. This is really for those people who've never seen u sub before. I'm building my way up to it. So isn't that the same thing?
Yeah.
It's integral of square root of something, d something. Well, how do you integrate u?
Just
Square root of u.
1/2.
So it's u to the 1/2. How do you integrate that? Help me. How do you integrate u to the end?
N plus 1.
3 halves.
2 halves.
2
Thirds.
thirds. There it is.
Plus C.
And then what is u?
U is x squared plus 1.
Yeah, so it'll be 2 thirds. Alright, so now watch. Help me out here, help me out. What is, now stay with me. So if that was given to me like that, which it never will be, it will almost never be given to you like this. And if it was given to me like that, I could do this. So you're like, well, Jeff, what the hell did you do all this shit for if it's never going to be given to us like this? Because this is how it's going to be given to you. What is d x squared plus 1? You can do it, the d is just the total differential. I don't know if you guys remember this. The derivative with the dx on the end. Because I've taken the dx down here and put it over there. What's d by dx of this?
2x.
2x. So d of this is 2x dx. So if you're given this, 2x rad x squared plus 1 dx. Do you see an inside function?
Yes.
Yes, what's the inside function? Do you also see its derivative in there? Yes. Therefore, I can use u sub. So here's how u sub, and u sub really is just doing everything we just did here, just in a more formulaic way, just in a more recipe-ish way. And then the more complicated the functions get, you don't have to get all freaky with it, you just do what we're about to do. And I'm going to teach you the right way. And the other way is not the wrong way, it's just the way that really opens the door for all kinds of neat mistakes. So why the hell teach it that way? I don't know. So, if it's given to you like this. Okay, it's given to you like this. U is the inside function. X squared plus 1. To be honest, not always, but for right now, let's say u is whatever's going to make the integral work. Du is just the derivative of what I just put down. 2x dx. Good. So du, normally it's du dx, but I just pull it over. We've seen that before. We've seen that total differential before. We've seen that. And I think at that point it said they're going to use this in integration later. Here we are. We're there now. Right? We are in the future. So now rewrite the integral. 2x dx is du. So it's much better to do it this way. You've got to trust me on this. Because then I can see that I have what I need. I can see that I have what I need. There's another way to do this where you just start throwing shit in there and you don't know if you have what you need. And some of the integrals are happening that should never happen. So if you don't know the other way, good. That's a good way to be. You don't know what the hell I'm saying right now. Be fine with that. Say that's the way to do it. And go, yes, I will do it that way. Right? If you come up against a teacher that doesn't want you to do it that way, slap him. Slap him in the face. So how do I rewrite this? 2x dx is du. Square root of u. And then of course we just do what we did over there. That'll be u to the 3 halves, 2 thirds plus c, and then you replace u with what it do be. How would you check that if you're taking a test? You would just take the derivative. Right? And then if you take the derivative, it should come out to be that. All right, let me stop there for a second. How do you feel so far? That's exactly tied into what we did earlier that we had talked a little bit about before. It's exactly the same idea. And it's just like u and v sub with the cubes thing. You're just making it look better. This is the same form as this. It's exactly the same form as this. So if I can integrate that, I can just replace that with what u is in this form. Maybe. So what if I had this? You help me create a problem that'll work. What you got, Jeff? I don't know, man. Jeff, leave me alone. What if I add this? Let me leave this open. What would I put in there to make this work?
3x plus 4.
Yeah, exactly. 3x squared plus 4. Do you guys see that? So now if I try u sub, well, where'd that come from? That is the derivative of the bottom. So if this is what was given to me, I see a function inside of 1 over x. I see x cubed plus 4x, it's inside of 1 over x. Is its derivative in there also? Yes. That means I can do this. And I'm going to show you some nifty stuff later that it's going to expand our rules, but right now I'll stick with that. So if I let u equal what?
X cubed.
X cubed plus 4x. What's du?
3x squared plus 4.
3x squared plus 4 dx. So that is du,
Over u.
and that is u. Let me stop there for a second. Make sure you guys are with me.
No, you can't.
What's the matter?
I hope. Just yeah. Sorry. Never mind. Keep going.
All right, I'll let you be helpful. Hopeful. And helpful. That is what?
ln of u.
ln of,
Absolute value of u. Plus c.
so it's ln of,
3 x cubed plus 4x. Oh,
now think about it. Isn't that, now think about it. This totally made, if you took this guy's derivative, what would it be? 1 over this times the derivative of this. And of course the c goes away. The derivative of c is 0. So really, this is just a direct answer to chain rule. The integral says, all right, if I got a function inside something else, I better at the same time have its derivative there. If I don't, I'm screwed. So if I give you this to do, let me not get to too freaky stuff yet. We're not in freaky stuff yet, believe it or not. If I gave you this to do, what would you say right now? Can't do it. Cannot. What's missing?
Its derivative.
Yeah, what's its derivative?
3x squared.
Alright, so let me do a problem, make sure you understand that the constants don't matter with shit. It's like the game whose lines anyway, just like the points. And I think, no? Okay, it's too long. So what should really be here to make it work perfectly is 3x squared. So let me, of course, put 7x squared there. So this integral as it's given, not doable. Doable. This is completely doable. Because I do not care about constants. I do not care about them. Poor little constants don't care about them. I don't. Because I can take the 7 out of the way. Boom. So that's one thing. All right, that's nice, Jeff. But I want a 3 there, don't I?
So you put a 3 there.
So you put a 3 there. If I put a 3 there, what do I have to do? Let me put it in a different color.
Divide by 7.
Different color, Jeff.
Divide by 7.
Yeah, if I put a 3 there, I better at the same time put an over 3 out there. That is so much better than the other way. I know the other way is nice, but it just leaves the door open for mistakes. And this way, you're being much more direct with yourself. You're creating what it is you need in the problem, right? So what's u? What do you be?
X cubed plus 1.
And so du is?
3x squared dx.
And I made 3x squared dx show up. All right, let me stop there for a second. See people squinting. Like, what? So I have an inside function. I know I'm trying to undo derivatives, so I have to have its chain rule piece with it. Constants, I can change them to be any damn thing I want to. You want 1,000,000 there? Put over 1,000,000 outside. You can do anything you want to as far as constants, except for 0, of course. Don't go crazy. 0 has all its problems. It always has. What matters is, do I have the heart of the x piece that I need, right? If it's x cubed plus shit, I need x squared outside. And the constant, I'll make it work. Who cares? I really want to hammer that home. So it's not that you don't have to make it work, it's just that you can make the constants anything you want them to be. Just do it right and you're fine. The thing you can't do, if that was just an x, oops. Actually, you could do something, believe it or not, we'll do that next. I'll show you. So this is the basic idea of U sub. It is a direct answer to chain rule, but it also is more than that. It is a substitution method to make the integral look more like something you can do. So it's actually, you can do more with it. So before I get all freaking, I'm going to give you a few to try on your own. Let's finish this one out though. This will be 7/3. That's out there. 7/3 integral.
U to the
U to the 1/2.
du.
And this all is du. I love it. So that is the same as that. They are the same thing. So this is 7/3 times 2/3 u to the 3/2 plus c. So it's 14/9 u to the 3/2. Let's make u what it is. What's u? What's u? X cubed plus 1. X cubed plus 1 to the 3/2 plus c. Wow.
So
Okay. So here, you guys try these.
Ready.
Good. Even if you're not ready.
Maybe. We'll see.
I think I know what's going down. Wait. Oh, so you keep breaking it.
you had a picture.
What's the matter?
If you don't be quiet, I'm going to put some limits out here that requires you to actually use trig. Right now, who cares that it's trig? We do, Jeff. I understand.
So amazing.
Something more interesting.
To it.
Oh, I got you. Alright, let me stop there.
So if we take out a 2,
So that's pretty much a good idea. If you're not sure what to do, start with u and see if something can be done.
Is you secret?
Use, no, what's the inside function?
Oh.
X squared plus 2. So that's a good place to start.
So the idea is to make the outside equal to the
Derivative of the inside.
Yeah.
Yeah.
Equal to du and make the inside. Alright.
Like, I don't get a secret thing.
1 over.
Now listen, if you have any trouble with this, if I ask you to take this guy's derivative, which I'm not, I'm asking you anyway, but if I did ask you to take this guy's derivative, a chain rule would happen, right?
Yes.
And the chain rule piece would be 2x. Is that cool? So you kind of think that way about integration, because integration is directly related to differentiation, obviously, right, to derivatives. So that's there, thankfully. It's an answer to what would come popping out of here. Do you guys understand? So this is going to be inside of whatever trig function that is the derivative of. So that's still going to be the inside. So it would have a chain rule where it would need 2x to show up. And as Christian just gave away a second ago, I can make 2x show up there really easy. I just have to pull something out of the way. Of course, if you don't know your derivatives, you're going to die very quickly. Right? I'll just have to push you to the side of the room as people die. If you don't know where secant squared comes from, for example, there's no way you can integrate. But you should know where secant squared comes from. Right?
You have to go out in the sun to get it.
I thought your mama and daddy would have had to talk. Let me tell you where secant squared comes from.
There's a time when it comes.
The trig store comes.
Oh, you did?
Second one's actually the easier one, I guess. They're both about the same easiness.
So this is du is equal to 2x dx.
The second one, the u is x.
Tan.
2x plus 1.
Yeah, 'cause
No.
this is
Oh, yeah.
X squared plus x.
2x tangent.
So let me ask you this. In the first piece, we have secant squared, which is like the body of the problem. It's like it's going to tell me it comes from what? What's it come from? Tangent. So that's what that tells me. But then I've got this is a candidate and this is a candidate for doing something with. Which one of those is free to go with dx?
4x.
4x. So that's got to be related to the du piece. Because du is going to be blah dx. Do you understand what I'm saying? So a part of this and this together go to make du. That means this guy must be u. It's not me. Yes. Yeah.
After you've taken du, then doesn't that go away temporarily and then come back when you're putting,
All right, let's find out. What's u?
It's
2x,
x squared plus 2.
or 2x
Careful. That's u.
du.
And du is
2x plus
2x
dx.
dx. So like we said,
You can take a 1 4.
split 4 up is 2 and 2. So I have twice the integral of 2x dx is du. Secant squared of u. And the integral secant squared is tangent. And u is... Alright, now which part do we have trouble with? Make sure you guys are with me.
Wait.
Oh, you got it out. That's right.
Yes.
So you took out, you couldn't have just made it 2x times the secant squared, or you had to take it out?
You could, now listen, you could rewrite this, take a 4 out of the way, and then you put a 2 there, so you're going to divide by 2. Either, anything you do is going to end up with a 2 on the outside.
Oh, because I took the antiderivative of 2x.
So that's not good.
So you're not supposed to do that.
Yeah, no. So you want to take the integral with respect to x and replace it with an integral with respect to u that's in an easier form. It's actually in the same form, it just looks better. Just like when I did u and v earlier, it became u cubed minus v cubed. That's easy. And before I did it, it looked disgusting. All right. What about the second piece here? What's the inside function?
X squared plus x
Yeah.
plus 2.
And what's du?
2x plus 1 dx.
Thank God that 2x plus 1 dx. If the du would have been 4x plus 2,
You would have done the same.
I would have just had to multiply by 2 and divide by 2 to make this 4x plus 2, right? I like it. If you're missing an x, there ain't shit you can do. Either you did it the wrong way or it's not doable. There are many integrals that are actually completely undoable by hand. You just can't do them. It's too bad for us humans. Some of them we can do with an infinite series. Yay, 280. So how do I rewrite this? Yeah, e to the u, and this is du.
And then when you do
The
that,
integral of eu is, and u was
x squared plus x plus 2.
plus c. Yeah, careful of that plus c.
Plus e. Plus e. Plus e. It sounds like you're saying plus e with a y. Plus e.
I'm with you. It's another bad character in South Park. Italian.
That's the best character ever.
That's awesome. We got a little calculus mascot. Don't forget your plus. Sal, you're the worst. I know. All right. My talents. All right. So, all right, let's do a couple more normal ones. Then I'll do a couple of weird ones, and we'll call it a day.
That was normal?
That's normal all day long. This is classic problem. This is classic U sub. Nothing weird about it. I've got an inside function. Its derivative is available for me. You with me? Constants, I don't care anything about it. If that would have been a square root of pi there, I would just take the damn thing out of the way. In fact,
That's what you do.
on the heels of that note, let's see. What else you got, Jeff? I don't know, man.
So
Not much.
the du means the derivative.
Yeah.
So e to the d, you're taking the derivative of e to the u, which is that. The reason that's okay is because you define u to be the
You had to
derivative
say pi.
of u.
Yes.
And
Not
e
pi. Square root of 11. Is that
Square root
pi?
of 11. Square root of 11.
Oh, okay.
if you took the
You
derivative,
square root of 11 pi.
you get
2x plus 1 times.
Let's see.
Don't make it x plus 2.
yes, that is the derivative of u, but e to the u is e to the x squared.
Is this
Times tangent.
Because
Like,
remember,
wait, this-
so
and
What's up?
This is the easy one.
This is an easy one.
This is an easy
yeah,
one.
the anti.
This is a gimme.
So just like in the first
This is the easy part.
going backwards,
Now listen, hey, guys,
then it would be
guys.
e to
The whole point of U sub is to take what is admittedly an ugly looking integral and very quickly making it look better. So your first concern is, what will I consider to be the inside function?
You gotta have to.
So like for this one, how do you know which one is the inside function?
I like
Would it be the negative one?
You have to use like the.
Where are we looking? Sorry.
For the
Yeah, so if I rewrite this a little bit, let me rewrite this. Won't that go down here?
yeah.
So can you guys got to start thinking about which part of that which part of this is stuck where it is.
This is the one on top.
This is stuck here. I can't. This stuff I could put it with that. I could put it over there. I could take that out. Stuff on the top is freer. Stuff on the bottom is stuck. It's inside a 1 over x function, and I know what the integral of 1 over x is. So this is in the form 1 over x. Believe it or not, it totally is. I just haven't uncovered that yet. So you start with your first point is what is the inside function?
Which one's
X
that?
Yeah.
Because his derivative
There's element.
is actually in there, believe it or not. Just got constants in the way. So if I let u equal x squared minus 6x, I get du.
Minus 9 then?
Say again?
Are you sure it should be minus 9?
Yes, I am.
What?
I appreciate that. But keep going. You can't think. Don't try to think ahead. Just do it. So what do you get here?
2x minus 6.
So I need to find this to put with my dx, right? So the first thing I do is just take the square root of 11 out of the way. What else can I take out of the way?
You can put
3.
A 3, right?
You,
9 I can't do shit with because it's not a factor.
yeah.
I can take factors out and in because I can multiply and divide it in and out.
So x
So what I have so far, I got x minus 3 on the top, right? Is that cool?
Yeah.
Over x squared minus 6x dx. Now, is that what I need it to be?
You mean
No, you
2x?
multiply it times 2.
So what am I missing then? I need to have a factor of
2.
2. So if I put a 2 there,
You have to put a 1
I
out
put it in a
outside.
different color.
Yeah.
All right, let me stop there for a second. You good? And again, this is going to take a little, obviously, it's going to take some getting used to because whenever you learn something new, you got to learn what you're allowed to do. Constants, I'm going to keep saying this. They go in, out, I don't care. You can pull it out, you can put if you put something inside, you better divide it. If you put something on the bottom, you better put it on the top outside. It just depends on what you need where. You can, constants, you can put them wherever, as long as you balance them out. You can do whatever you want to. Variables, you're stuck with whatever's on the inside. If you're missing an x, you can't go, all right, give me something. No, you can't do that shit. Right? Especially if you sound like that. Alright, so now what do I have? I have square root of 11 times 3 over 2. Now I happen to rewrite this. 2x minus 6 dx is du. X squared minus 6x is u. This is rad 11, 3 over 2 times,
11 plus absolute u plus
right? And then you replace u with what it is. So see what I said earlier, this was in the form 1 over x. And it took a little bit of doing, but we uncovered that form, 1 over u. We uncovered the form it was in. The form is what's important. So then we get rad 11, 3 over 2. Natural log of x squared minus 6x plus c. So you better make sure that your n variable is the same as the variable you started with. Don't end in u. All right.
Does u become a constant? Why would it become 1 to u?
Where's 1?
You said it was 1 in the form of 1 over u.
Yeah, it's 1 over u.
Oh.
So I mean, I put the du on the top.
Never
I
mind.
could put
Sorry.
1
Sorry. Yeah.
I could put it like that. Yeah, cool. Understood one. Alright, so let's do a couple of freaky ones, and then I'll release you. And then we still have to talk about how does this work with definite integration. These are indefinite intervals. There's no limits. So how does this work with definite integration? Works the same way as always, don't freak out.
Is this 5 to 5?
This is 5-5 stuff,
but don't freak out.
This is 5-5. Yeah, the work is freaky. Don't yourself freak out. All right. So what about somebody help me out? What's yeah?
So you is
What's kind of wrong with this that actually we can still do something with? By the book so far, can we do U sub?
No.
Why not?
You received X.
What's if U is x plus 1? Du should be
1.
so there's like an extra x. Can I take the x out of the way?
No.
Some people will, even though we just said we can't. I don't blame you too much because the human spirit, we just can't. You can't get it past that, dude, right? Because this depends on x. No x stuff can come out. Just like no n stuff can come out of the limit, no I stuff can come out of the sum. That's exactly what this is. So related to all that, put together. So now watch this. You can actually do something.
I'm ready.
So what is U?
X plus 1.
This is where we start to realize it's more than just chain rule. That's one thing it does. It answers chain rule, but it's more powerful than that. It is a substitution. As long as it can replace every x thing with a u thing, I can see if that new integral is easier to do. Watch what happens. This is kind of cool.
Okay.
So, I mean, du is what?
1.
1. dx. But watch, if u is x plus 1, what's x?
dx plus 1.
No. If u is x plus 1, x is
U minus 1.
u minus 1. So, if I can replace all my x shit with u shit, then I'm not calling you shit. I gotta watch out for my grammar when I teach u sub. What do I get? Integral, what's x?
U minus 1.
u minus 1.
Rad U minus 1.
What's x plus 1? U. And what's dx?
Du.
Is that an easier integral to do?
Oh yeah.
Why?
You can distribute.
I can distribute. Couldn't do that before, could I?
No.
Right? I don't know if you guys... Now again, you're just seeing this, and sometimes teachers gloss over this, but I want to show you U sub is useful to answer chain rule. Integration always has to be able to undo whatever differentiation was done. That's what integration does, primarily. Right? So it's its answer to chain rule. But U sub goes beyond that. This is not a chain rule. There's no chain rule here. But U sub still is useful. Because it's more than just a chain rule answer. It's a substitution method that sometimes, look, this was 2 terms, right?
Yeah.
So by doing the substitution, I made it 1 term in there, which makes it possible to do that. So let's see. Yes, sir. All right, thank you. What do you get when you...
You did 3 half. Minus u.
And what's the integral?
2/3.
3 plus 2?
5.
5 halves. And front end would be
2/5.
2/5. So write the power first, right? Minus u to the
3 halves.
3 halves. And front there's
2/3.
2/3. And u was x plus 1. So if you took that guy's derivative, you would end up here.
Wow.
It's kind of cool. Yes, sir.
So say, how do you know which one or which process to use? Because obviously you couldn't tell that what do you call it, the derivative was in there as obviously.
If it's not an integral that you can do directly, the only next level thing we have to try is U sub. So right now in this class, if that wasn't there, I could do it. I don't know if you guys understand. We can totally do that.
Yeah.
That's just x plus 1 to the 1/2. I can integrate that. That made it not. I can't do it directly. The minute I can't integrate it directly, I have to try U sub. And then you have to be more. Then you would go, well, that's not chain rule. All right, well, let me try this. Now you guys know this. If you can write u equals the function of x, you can solve for x and replace x with shit directly with u. It's all about substituting. Get all the x's to become u's. Woo! That's our first step into the incredibly important substitution rule, U sub. Oh, by the way, What's happening Wednesday?